Good morning. I welcome you all to the series of lectures on thermodynamics. Today we are going to discuss about the problems on Carnot engines, refrigerators and heat pumps. Now this problem indicates three Carnot heat engines. See, three Carnot heat engines are arranged in series. For the first engine takes 4000 kilojoules of heat from a source of 2000 Kelvin and delivers 1800 kilojoules of work. See, the first engine takes Q1 value, that is 4000 kilojoules of heat. Q1 is 4000 kilojoules of heat and delivers of heat from a source of 2000 Kelvin, that is T1 is 2000 Kelvin and delivers 1800 kilojoules of work, that is W1. See, car engines are arranged in series means the exhaust of first engine is the intake to the second engine, that is Q2 equal to Q2. The exhaust of second engine is the intake to the third engine, that is Q3 equal to Q3. See, so that means when the engines are connected in series, this is the order, and delivers 1800 kilojoules of work. The second and third engines deliver 1200 kilojoules and 500 kilojoules of work. W2 equal to 1200, W3 is equal to 500 kilojoules of work. Now, made calculations for the exhaust temperatures of second and third Carnot heat engines. So that means second engine exhaust temperature is T3, third engine exhaust temperature is T4. That we need to calculate. Now this is T1, T2. Between T1 and T2, engine 1 is there. Q1 and Q2 is the heat interaction. So work transfer of engine 1 is Q1 minus Q2. Same Q2 is supplied to the engine 2. The exhaust of first engine is supplied to the second engine. So Q2 minus Q3 is the work W2, and the third engine is between T3 and T4. So same Q3 is supplied to the engine 3. W3 equal to Q3 minus Q4. Now efficiency, first let us consider engine 1. Efficiency of engine 1, this engine. The formula, this is a Carnot engine, so you can write in terms of temperatures. T1 minus T2 by T1, that is T1 is 2000 minus T2 by T1 is 2000. So you can, from this you can calculate the efficiency of heat engine is, you don't know T2 value. Then you have another formula for the heat engine efficiency, that is W net by heat supplied. W net, first engine W net, the first engine work output is 1800 by Q1 is 4000. 1800 by 4000 means it is 0.45%. Then 0.45 is equal to 2000 minus T2 by 2000. So you will get T2 equal to 1100 Kelvin. From this, W net equal to Q1 minus Q2. If you know Q1 value as 4000 and W net as 1800, then you will get Q2 value as difference of these two, that is 4000 minus 1800, that is 2200 kilojoules. Now let us go to the engine 2. Engine 2 is Q2 is equal to, already we calculate Q2 equal to 2200. The same engine, whatever the heat that is delivered by the engine 2 is supplied to the engine, whatever the heat that is delivered by the engine 1 is supplied to the engine 2. So Q2 is equal to 2200 kilojoules. Now T2 equal to, already calculated, 1100 Kelvin. W2 equal to given 1200 kilojoules. So from this, W2 equal to Q2 minus Q3. So Q2 minus Q3, you know already Q2 value, W2 value, you get Q3 as 1000 kilojoules. Now engine 2 is also a Carnot engine, so you can write Q2 by Q3 equal to T2 by T3. So from this, you know Q2 value, you know Q3 value, you know T2 value. See, Q2 you know, Q3 you know T2 also. You will get T3 value from this, that is 500 Kelvin. T3 equal to T2 into Q3 by Q2, all values you know, so T3 equal to 500 Kelvin. Now efficiency of engine 2 is W net of engine 2, that is W2 by heat supplied, that is Q2. Heat supplied is Q2. So W net is equal to Q2 minus Q3. So Q2 value is 2200, Q3 is 1000. 2200 minus 1000 is 1200, already has given. W2 equal to 1200. 2200 minus 1000 is 1200. He has given directly W2. 1200 by Q2 value already we calculated 2200. Then it is 54.5%. Now let us go to the engine 3. Engine 3 efficiency. Before that, Q3 is equal to, Q3 is equal to 1000 kilojoules. Already we calculated Q3 value. Whatever the heat that is rejected by engine 2 is supplied to engine 3. So Q3 is equal to same 1000 kilojoules. T3 equal to 500 Kelvin. W3 has given 500 kilojoules of work. Now W3 equal to, anyway from the diagram also, Q3 minus Q4. So everything. W3 equal to, Q3 value, W3 value. So you'll get Q4 as 500 kilojoules. It is Q3 is 1000 minus W3 is 500. So you'll get Q4 as 500 kilojoules. Engine 3 is a Carnot engine. So you can write Q3 by Q4 equal to T3 by T4. So from this everything except T4. So T4 equal to 250 Kelvin from these three parameters. Then efficiency of engine 3 equal to efficiency equal to net work done. That is W3 by heat supplied Q3. W net by Q3. So W net already the W net he has given for engine 3. The W net is 500 kilojoules. From the calculation also you can calculate W net equal to, from this engine W net equal to Q3 minus Q4. So Q3 is equal to 1000, Q4 equal to 500. So that is also 500. 1000 minus 500, 500. By Q3 is 1000. So it is 50%. So we calculated everything here. They ask you to calculate T3 and T4. So T3 value calculated, and T4 value also calculated. The temperatures of the inlet, exhaust temperatures of the second and third engines, that is T3 and T4. Thank you very much.